All right, let's go through a problem very similar to the one we've just seen. We want to show that this has no solutions. So to do this, it's going to be basically the same procedure. We need to match up both sides. Remember that two fractions are equal. It's quite a complicated expression, right? A divided by B is equal to C divided by D. It's a little bit complicated. It has to be AD is equal to B times C. But if the denominators are the same, it's much slicker, remember, right? So just recall again that A over B is equal to C over D, or C over B, let's say, same thing, if and only if A is equal to C. Okay, and of course, this is all assuming B is not equal to 0, otherwise the left-hand side wouldn't make any sense, right? So that's kind of an important point. So what we want to do is make these two sides exactly the same. And thankfully, I can see the left-hand side. If I was to multiply the denominators together, I would get a difference of two squares. It would kind of match up perfectly. So this expression on the left-hand side, let's deal with this first, is equal to, okay, so let's make the denominators the same. It's x plus 1 divided by x minus 1, x plus 1, plus x minus 1, or divided by x minus 1, x plus 1. Difference of two squares. So I would end up with what? I would end up with x plus 1, so I'll do it very carefully, x plus 1 plus x minus 1, all divided by x squared minus 1, very nice. And that comes out to be equal to what? 2x, the constant term disappears, 2x, x squared minus 1. So what do we need? So 2x x squared minus 1. This is the left-hand side. We need this to be equal to 2 divided by x squared minus 1. So this is going to be if and only if what? Well, 2x is equal to 2. And of course, very importantly, we can't have the denominators being 0. X squared minus 1 is not equal to 0. So we need both of these things to happen. So this is if and only if what? Well, the first thing is x is equal to 1, of course. Okay, because we just divide through by 2. And what else has to happen? Well, x can't be equal to plus or minus 1. Because if it's equal to plus or minus 1, the square is going to be 1, so the difference with 1 is going to be equal to 0. This is impossible, right? This can't happen. You can't have something which is 1 and then not 1 simultaneously. So this cannot happen. Both cannot occur. Okay, so this implies there are no solutions. Because any solution would have to satisfy both of those. There is no solution to this. So exactly the same kind of problem. If you weren't paying attention, so if you weren't looking out for the fact that denominators need to make sense, so if you'd forgotten this, you could very easily just pick up this alone, but it wouldn't make sense, because if I feed 1 into either side, it ends up with 0 in the denominators, which doesn't make sense. So this is a classic extraneous solution problem. If you're just blindly doing the algebra without really carefully thinking about what the conditions are, you can easily miss things out. And this is the piece of algebra we're really using at the top here. And this is crucial, right? Because if you miss this, then it is easy to kind of fall into this trap.